back to Virtual MOSI. Today we're going to be talking about something that is kind of relevant right now for a part of the world. We're going to be talking about air filtration. So right over on my side, if you may see some smoke, we do have a fire happening over here, and it's safe with our fire expert over here, Chris, and we're going to be talking about the filtration device I have set up over there. While that's going on, we're going to be talking a little bit about an inventor that is local here to Florida, especially right across the street from our museum here at MOSI, over at University of South Florida. So we have Dr. Goswami, who is a chemical engineer professor over there, and he created a very, very cool air filter using his engineering skills. So his son suffered from very bad asthma and allergies, and at that time there weren't really many options available for them to help clean the air that was around him. So he took into his own account trying to figure out a way that they can filter out all these different things you can see in the air, especially the smoke that we see right here. And he created a company and an air filter called the Molecule. So the Molecule is really cool because it can filter out many more things than the normal HEPA filters can. So what their technology does, I don't want to get it wrong, so I'll write it down. It is the PECO filter, which stands for photoelectrochemical oxidization. So what this does is actually something very, very cool. What it uses is free radicals, the same thing that we use to kill cancer cells, to kill and get rid of the different things that live in the air. So what that means is it can filter out and get rid of more things than just the normal pollen particles that are in the air, but it can get rid of things like the common cold virus and different things like that. I'll list a few other things in just a minute, but I want to show you how the filter actually does work. So I'm going to show you right on this table really quick. I have some different things. So each picture is going to kind of represent how the filter works. So this one right here, that is the symbol for the free radicals. So the free radicals are the most important part of the filter. They combine with the oxygen to kind of attack the different viruses we have. After that, what is made is going to be the result of what's left over is going to be CO2 particles, which is what we breathe out, so carbon dioxide, water, and nitrogen or other base elements that are around here. So things like nitrogen, hydrogen, all the things that exist naturally around the world. So what it does is it takes these things over here and turns it into different chemicals and things that already exist in nature. So it doesn't release anything like ozone or anything like that that could be definitely harmful to the environment. So what the filters can do is actually really cool. So the filters can filter out, like I mentioned, the common cold virus, tobacco smoke, DNA viruses, different allergens from different insects like cockroaches, pet dander, black mold, pollen, and different bacteria spores. So the way it does that is through those free radicals. The free radicals attach to it and slowly decompose the structures, and it gets rid of it. Again, it's not 100% sound. It's going to have to take some time. But that is one really cool thing that these filters can do. So now let's go ahead and head back over to what Chris was doing, and let's see what the filters themselves actually do. So, Chris, you're going to go ahead and stop doing that. So right here, I have a very simple filter that I put together. It just is made up of very simple things, like I have a cardboard box and just some coffee filters. Right on the other side, I just have a paper towel. Normal, regular air filters are going to have a lot of different things to it. This is not an actual air filter, it's to represent it. So this part right here is the first layer of where we filter the air. So this is going to be catching the large particles, mostly from the smoke. It's going to be the different burnt particles, mostly like carbon and such, that gets pushed through here, as well as whatever else is in the air right around MOSI. If you look up a little bit close, you can see some different particles that got put on there. Those are going to be mostly carbon atoms from the different pine needles that were burnt. And then on the inside, I had another set of filters. This one right here caught, again, the second layer. So what is in there? It is a thick layer of different items that are going to kind of collect all the smaller particles inside. So the way this works is kind of similar to how the Molecule air filter works as well. So what happens with the Molecule air filter is instead of being sideways, it's going to be right side up. and it sucks in through the bottom and puts the air out through the top. What it's doing is in the bottom, it's going to be going through a normal HEPA filter, like I mentioned earlier, is pretty much the standard for air filters that you're going to find everywhere around. And that is going to be enough, it's going to be small enough to be able to filter out pretty much basic dander and pollen and things like that that you don't want to breathe in. But as soon as it goes through there, it's going to go through another stage of filtration, and then it goes through those free radical ions that I mentioned earlier that are going to kill things as small as the common cold virus, which is very, very important. And that's something cool there. So if anyone does have any questions about these filters, feel free to ask. I'll definitely be able to help answer those in the comments later. Hope everyone had a great day, and